Because of the weight and the velocity, it will move in a parabolic path. When it is moving in parabolic path, this ball, at one instant you can see it is at same height, no? At two different instants of time. Means at t equals 0, I'll kick the ball. Let's have this weight mg. It'll be easy for you. At two different instants of time, the projectile will be at same height. Let me choose this one. You can see this one. It will be at same height at t equals 0 at time t1. Here it will have velocity up. And it will have the same speed here. It will not, velocity will be different, but the speed has to be same. And let's go for other things. Here, u cos theta, u sin theta, vx, u cos theta, vx, this will be vy, u cos theta, u sin theta. At time t equal to t1, it will be here. At time t equal to t2, it will be here. So we are projecting from the ground at point 2. It is a ground. Then let me call this as A, this particular point as B. You can see colors. Okay, fine. So what is T1? T1 is the time taken to move from O to A. What is T2? T2 is the time taken to move from O to B. And let it be C. And time of flight is what? TOC is equal to time of flight. Time taken to move from O to A will call T1. Time taken to move from O to B will call T2. Time taken to move from O to C is what? The time of flight. Let's see how all these three are related. So we are trying to get a relationship. This one. So let this projectile be at an instant. We'll write equation for H. That one here, gravity, G is acting. We'll write all the possible equations. H is equal to u sin theta t minus gt square by 2. Now you have to ask question. Sir, why this H positive? Because you are measuring displacement in the direction of initial velocity. That's why H is positive. And you are measuring this G opposite to initial velocity because G it's downward. So therefore this negative sign. Rest all, I think when you are applying equations of motion, the sign for displacement and acceleration depends upon the initial velocity. We are discussing motion of the body, equations of motion along y-axis here. Then there's a quadratic equation, we'll solve this. This will be gt square by 2 minus u sin theta t plus h equal to 0. Quadratic equation, t equal to u sin theta plus or minus u sin theta whole square minus 4 minus 4 AC. 4 A is G by 2 and this is H by 2A. 2 into G by 2. This will end up with u sin theta plus or minus 2GH O divided by G, or this will break up into two parts. The first one is T1, U sine theta G minus, and what about the other one? The other one is U sine theta by G plus U square sine square theta minus 2GH all divided by 2. There are two times are there. We'll add up these two times. So means what is happening? The projectile will be at same height at two different instants of time. Right? And what are those times we are having? This one. We'll add up these two. What do we get? T1 plus T2. T1 plus T2 means I should add up these two. Let me use. I'll substitute the value. Then this T1 plus T2 will be 2U sine theta by G, which is nothing but equal to time of flight. Oh, we are having very beautiful equation here. So what is the conclusion? Time taken to move from O to A plus O to B is equal to time taken to move from O to C. Or if you break up further, TOA must be equal to TBC. It has to be in a projectile. This what happens means what time will take to move from O to A. It will take same time to move from B to C. And what is the time interval between from as it moves from A to B means? So we can calculate that TAB also. So how to calculate TAB? TOB minus TOA. This will be directly equal to U square sine square theta minus 2GH I'm writing it. What is TAB? Time taken move from here to there between the same height. This will be useful. So somewhere in our formulas, this is going to help us a lot. The reason for that, T2 minus T1. So this quantity will get added up to this. These two will cancel out when you add up T1 plus T2. So like this, all when the projectile will be at same height twice, it will be at same height at two different instants of time. And what are those instants of time that we are calculated here? And some of those instants of time should be equal to time of flight. So what is the basic conceptual question? How do they ask you? The projectile will be at, let it get safe. The projectile will be at same height at two different instants of time, and the sum of those heights and the sum of those times must be equal to total time of flight. I think there's one statement we have conceptual. We should the projectile will be the same height at two different instants of time. This sum of this time is equal to time of flight of projectile. You have this statement. For this statement, the above thing is what explanation. Without the all this mathematics, no, we can't justify this statement. In physics, there's nothing called like a conceptual question. Everything again is numerical only. Even if you see any one statement, so what you have to do, like you have to work out a numerical. You have to show that how that particular statement is justified with some examples. We have to show it. We can't just read this statement. Okay, sir, this statement. Okay, fine, sir, we will remember. No, everything is background needed. All this. Okay, kids. Now we'll take the next concept. Next topic will go. Okay, we'll continue with the same idea. So I'll project the ball with a speed. It will move in a parabolic path. Twice it will be at same height. At what are the instants of time at t equal to t1 and t2? The projectile will be at same height. Then what about these positions at t1, t2? The ball will have horizontal distance c, and from the point of projection at distance b, and this will be the range. Let's see that how this a, b, and r are related. We'll try to bring this equation. Now, if this is a, so what is this distance will be? R minus a. If this is b, this has to be r minus b. And we know the time taken to move from O to A is equal to B to C. And the horizontal good morning, kids. We had the problem, so it was we have completed. So at t equals 0, this ball will be kicked by the footballer. So there's a ball. Because of the velocity imparted and the weight, it will move in a parabolic path. Okay, fine. This one. Then it will strike the ground at point C. Everything is a ground. Then look at this one. At two different instants of time, it will be at same height. At two different instants of time, the projectile, it will be at same height. Everything is ground.